Welcome to this session of the ALE Knowledge Cafe. In today's session, we will provide you with an overview of the network requirements to support an intelligent transportation system, along with some real-life case studies. Transportation systems are unique in that their infrastructures often cover a wide geographic area within a metropolitan area or between different cities. The equipment installation locations can be by the roadside, in subway stations, or railroad stations. And there's an increasing need to securely connect to devices in harsh environments requiring power over Ethernet. Hardened Ethernet edge switches, such as the OmniSwitch 6855 and newer 6865, are a good fit for these installations due to their support for long-haul fiber, gigabit speeds, fault recovery, PoE, and advanced Layer 2, Layer 3 protocol support. This is an example of a railway and trackside network infrastructure. The network is IP-based and typically has a two-layer ring topology with smaller subrings, linking groups of stations or entire lines and larger backbone rings aggregating the subrings. Our first case study is a rail tunnel operator in Switzerland. Gotthard Tunnel is the world's longest rail tunnel with 57 kilometers between Zurich and Lugano. It's a dual-bore tunnel and is used for freight and high-speed trains, achieving speeds up to 250 kilometers per hour between Switzerland, Italy, and Germany. The requirement was for voice and data communications in some very difficult conditions, and this project was done in collaboration with Alcatel-Lucent, now part of Nokia. Temperature extremes, as well as dusty conditions and a humid environment, were typical. In addition to that, the tunnel could only be accessed at either end and at two intermediate passages, with only a 4-hour maintenance window on weekends. So the environment and the accessibility constraints meant that the equipment needed to be rugged with very high availability and resiliency. The solution involved many aspects, as I was explaining earlier. However, for the network, it included ruggedized switches to support operations communications, emergency and standard phones, public address system, tunnel monitoring system, and tunnel control system safety cameras, 2,500 of them. In terms of benefits, we have safe and reliable operation of high-speed trains, as well as centralized monitoring and control from the tunnel control center. Why Alcatel-Lucent Enterprise? Simply put, no other company could offer the range of solutions that were required for this project. The tunnel officially opened on June 1st, 2016. With some differences in the subsystems and devices that are connected to the network, the same architecture and technologies are applicable to roadside communication on a highway, in a tunnel, or on city streets. Vehicles such as buses, ambulances, police cars, fire trucks, couriers, etc. typically use 4G or LTE uplinks on the road and Wi-Fi at the depot or station. Let's move from the track or roadside to onboard communications. This is to support CCTV, passenger information and announcement systems, and to provide Wi-Fi access to passengers. The rail-to-ground linkage will typically be LTE or 4G, but in some cases Wi-Fi is utilized. Each car can have its own device, but also cars can be interlinked either through wired Ethernet or Wi-Fi meshing to provide resiliency in the event of a device failure, as well as diversity with the possibility of using multiple providers and simultaneous connections. On-board device compliance with the relevant rail standard is required and identified on the slide. Similarly, in the case of road vehicles such as buses, ambulances, police cars, fire trucks, couriers, and courtesy shuttles, the services provided are similar. When the bus is moving, it typically will use 4G or LTE as an uplink. However, when the bus is in the depot, we can switch to Wi-Fi to download CCTV images and update onboard information and entertainment systems, etc. Our next case study takes us to North America, and in this case we are talking about in-vehicle communications. The customer is the Massachusetts Bay Transport Authority, They operate 1,000 buses in the greater Boston area with 380,000 trips per day. The requirement was to increase passenger safety and to reduce the incident response time. The solution was onboard video surveillance with 360-degree cameras. The video feeds can be accessed by police, including police cars, in real time through an LTE connection. And the solution also includes onboard video displays for passengers. It's the first deployment of this kind in the United States. The benefits include faster suspect identification and tracking thanks to real-time access to video feeds by police. It acts as a crime deterrent, and the passengers feel safer. A success overall. Alcatel-Lucent Enterprise serves markets that require environmentally hardened Ethernet products and solutions. In particular, we provide products for rail, which includes urban rail, mainline rail, and trains, intelligent transportation systems, or ITS, including road authorities, departments of transportation, highway traffic monitoring, and in-vehicle communications, utilities such as electric, oil and gas, and renewable energy, as well as shipping, which includes freight, cruise ships, and seaports. Intelligent transportation systems from Alcatel-Lucent Enterprise. We make IT simple. To learn more about network infrastructure for an intelligent transportation system, visit us on the web. Thank you.